So we will start at 5 5. It is 5:05. So we start with assignment. Okay. It is assignment number 4. So this is the problem solving and doubt clearing session. Okay. Number 5 for course AV 91. That is production technology and theory and practice. So for assignment number 4, so these are the questions and these are the answers which are correct. Okay. So my speed work is in being machine with tools specified as for this the typical ASA structure they are given here, and if average value of coefficient of efficiency and the tool is 0.05, so they are giving the chip that is mu they are given here. Mu is equal to 0.5, so we know the lambda is equal to tan inverse of mu. Okay, and then we get lambda is equal to tan inverse of 0.5. Okay, this is equal to lambda equal to 26.57 degrees. So when you get lambda, we know the Matrix circle equation. The Matrix equation for shear angle at 55 plus lambda minus alpha is equal to 90 degrees. Okay, this 90 degrees, keep it or not, that doesn't matter. So you get what you want, 5. You have lambda and alpha. Okay, here you can get is actually 8 degrees. Okay. It is in ASA. So this will be your rake angle, this will be your inclination angle, this is your inclination angle, and this will be your rake angle. You know this one. Okay, this will be your rake angle. So this is the rake angle I put here, and I showed many times, I think previous case. Okay, this is 5. Okay, so, so my 5 here for 5 is equal to 9. You can just change it. 90 minus 27.57. Okay, plus this make the equation correct that this number will go to that side, it will be negative and it will become positive. Okay, and divided by 2 because we need to calculate the 5. Therefore 5 is equal to 55.715. Okay, that will be a 5. Yes, 55.715. Yes, 55. Yeah, 5. Yeah. 5 is equal to 55.715. Okay, this one. Check it. Yeah, good. Yeah, 35.715. Okay, good answer. Good. Second question, a turning operation is performed with cutting speed of For diameter cutting speed is V is equal to 2 meter per second. Radius they have given and D they have given. So you ask MR, so you know your MR R is equal to V into F into D. Okay. So what is your V? They were given 2 into 10 raised to 3 meter because it is meter. Okay. And second is a correct. So okay. Within millimeter per second. Okay. Into 0.25 to your field into depth of cut is 3.0. Okay. So your answer will be 1500. Okay. Your answer will be 1500. Okay. Okay, so your answer will be 1500 millimeter per second. Okay. I show you everything that will be 2 into 10 raised to 3 because it is in meter per second, so it convert it to millimeter into 0.25 into 3. Okay. So if you just multiply it, you will get this answer. Okay. So this is your answer for the per millimeter per cube per second. Okay. This is your final answer. Okay. With very high normal pressure at a chip to interface, the ratio of the uh, real area of contact and the apparent area of contact becomes less than equal to or more than equal to 1 does not get affected. So I asked some kind of question in your problem set also, so what will happen in those cases. So your answer will be equal to 1. Okay. It is mentioned there equal to 1 because where the force is very high normal pressure. So when the pressure is very high, in that case that everything aspirated will degrade, means it will not affect anymore, and due to that very high pressure, due to very high pressure, this aspirated this will not have any effect, and it will match exactly because due to the very high pressure. So it will be equal to 1. So the correct answer. Okay, because to high normal pressure it is just. So it is mentioned in the slides. As working normal rectangle increases the normal stress field decreases. It's exactly same kind of question I asked you in that problem statement. So as normal rectangle increases, the mean normal stress will increase. It is there. You have the formula for that. So sigma average, k by sigma average, you know, okay, like this. K by sigma average is equal to your is your friction angle will be equal to the constant to tan inverse of k by sigma average. So it depends upon that. You do it when your normal rectangle will increase, your your nominal stress will decrease. Okay. This is your correct answer. Definition is as clear. With these equations. These equations, it will happen like that. Okay. For turning of a rod 20 millimeter diameter at rotating at 100 RPM, the speed is given is 0.1 per revolution. So, and depth of cut is given by 10. Then you know what is your MRR. Okay. You want to find your MRR. You know what how to calculate an MRR. Okay, it will be F equals A into BC. The cutting speed. What is the cutting speed is given? Here they are just giving the RPM, just need to convert your RPM into cutting speed. So you know that VC is equal to pi dn by 60 because it is in minute converted into seconds. That will be your pi dn. So what is your MIR then? You have field directly given. So 0.1 is given to you. 0.1 into d. What is your d? Is again given 1. Okay. Depth of cut is 1. And VC they have given again. Okay. So pi d you have 1, that is 1000, and by 60. So they also given a d. Okay. And it is 20. So this it will become 20 millimeter. Okay. It should become a 20 millimeter. They have given to you. Okay, so your answer will, because it is pi in is void here. So 104.72 millimeter cube per second will be your answer. Just multiply, simple multiplication here. You will multiply this, you will get this answer. Okay. Yes, okay. In shaping operation, we want to shaping operation now. The cutting speed is 5 meter per minute, speed is 0.2 meter per meter per stroke, and the depth of cut is 0.3 millimeter. The specific energy of the power is given. Okay, the specific energy, that is UC, is given to you. This 10 joule per millimeter cube. They will ask for power. What you need to find out here? MR. Because you know what is the formula for power? Power is equal to again UC into your MRR. And you know MRR is equal to what? Your MRR is equal to your F, your D, into your VC. This is shaping, okay? So VC is provided to you. You have field 0.2, you have depth of cut 0.3, and you have feed, but feed is in meter per minute. Okay, check this is properly. It is meter per minute. So we have to convert it into millimeter per second. Okay, so this is how we convert it into millimeter. Convert it into now millimeter per second. Okay, you know this is now millimeter per second. So we will now millimeter per second. So we will start go further. So this will be your MRR. So what will be your MRR now? Just this because the 6 will cancel out here, and it will be some 5. Because this everything will be cancelled out over here. Okay, and it will be 5 millimeter per millimeter cube per millimeter cube per second. Okay, so it will be 5 millimeter cube per second. This will be a second. Okay, what you now you have MRI. What you want power. So what is your power then equal to VC? VC you have, okay, 10. So 10 into 5, which is equal to simple 50 joules per joules per second. Okay, which is also called as watt. So it will be 50. It will be this will be 50 watt. This will be 50 watt. Simple. They are asking watt. Okay, so it should answer will 50. Okay, the single answer 50 watt. Okay, it's fine. Okay, it will be 50 watt. Okay, the answer is given there. Okay, so we have the answer 50 watt. Yes. So go to question number 7 now. A steel cylinder job of 200 millimeter length is being turned at 1000 rpm in 0.1 millimeter field. The time taken in minutes to machine the job is in one pass. Okay, so we know what is the formula for total time. We need to find the total time here. Okay, in one pass means in single pass only, but in total time we need to find out here. Okay, so what is your total time? What is the formula for the total time? So the total time you need to find out. Total time for machine. Total time for operation or machine design. Okay, for machine. Okay, is equal to L by F into N into N. Where N is the number of passes. Okay, so you know what number of passes they have given. This N is equal to 1. So your formula will become just L into F by N. Okay, what is your L? It is 200. Okay, 200 divided by what is the F? 0. The F is 0.1. Okay, is 0.1. Okay, and your N, you to find out N, which is given 1000. Okay, N is directly given here, which is 1000. But it is in RPM, you to convert it into seconds. Okay. Oh, then it will be equal to is equal to how much? 1000. Okay. 1000, you know 1000 is 1000. Okay. But it is in our rotation per millimeter. So it is in rotation per minute. So we have to convert it into per second. So we divide by 60. Okay, so divide by 60 means how it will become? Therefore our L by Fn is equal to 200 into 60, okay, divided by 0.1 into 1000. Okay. So again to be simple, like 1000, this 1000, this 1000, there is 0 there. So it's gone. Yes, so there is 0, there is 0 there. Okay. This 0, this 2 0 will gone. 60, 60 will gone. So what will take 120 is your answer. Okay, this is very simple answer. Your answer will be 120 seconds. Okay, because it will be converted into seconds. Okay, because it is in, the formula is in, according to the formula it will be in seconds. Okay, so that we need to convert into seconds, but what they are in minute. Okay, in minutes they are asking. You will see what they ask in minute, but they are need to convert it into minute again, because the requirement of the problem is that they are asking here to minute. We know divide by 60. So this is just a unit 2 minute. It is your final answer. Okay, 2 minute is your final answer. Okay, so in one part the answer will be 2 minutes. Okay, this is correct. Okay, so okay, a block like 10 millimeter hole is to be being drilled. So what right now we are doing, a 10 millimeter hole is being drilled in a mild steel block with a 500 RPM of the drill rotation frequency 0.2 millimeter per revolution of drill feet. So the material removal rate is not to calculate MRR again, but in this case the formula is slightly different. Okay, you must remember that formula. What is exact formula? It is different slightly. Okay, everything is given to you. So your MRR formula will be N by 60 into, this is a quite different formula. You know, that is 5 DN by 4 into your feed. You have your feed. Okay, so what is your feed? Again, you have your N also, it is 500. In this case, you need to keep just 500. Okay, it is in according to formula. It will take care of everything. So what is your diameter now? 10 millimeter. Okay, 14 10 millimeter. Then divided by 4 into F. Here is the field 0.2. Okay, your field is 0.2. So just multiply here by everything. So you will get answer which is 130.9, and this answer will be directly in millimeter cube per minute. Though we are, okay, though you are placing 60 here, but it according to the formula it could not have changed it. Okay, you need to be very careful with drilling case. Be careful. Okay, be careful here. because the unit will change here. Okay, this will be your final answer. 130. Okay, so 130 will be your final answer. 20.9. So they have given your range. Okay, so 130.131. Okay, the two one decimal point they have given. So it will, you can put like this. Okay, this will be your final answer in millimeter cube per minute. Okay, though we put here 60, but it is in the formula actually. Okay, be careful about this formula here. Okay, I mean about MRR here. We are doing in 60, but it is put in RPM only, and the answer we are getting is in minute again. Okay, be careful here. I mean, this point, be careful about this point. Again, I told you to be careful about this unit. Okay, don't do any mistake about this point. This is important point. Okay, this is important. Okay, this is important. Okay. For a problem given in question 8, if the specific energy consumed in process is 1.5 watt, the power consumed in the process in watt is. Okay, so what they say here from question number 8. So we have to give find what is your given here. So it will be 130.9. So your MRR. What you got from question number 8? MRR, which is 130.9 millimeter cube per minute you got, isn't it? Be careful again, you got in minute. And the energy consumed in the process what okay your UC is given here, which is 1.5. Okay, UC is given, which is 1.5. So what we need to do, which is joules per millimeter cube. So what is your power here? It is equal to UC into MRR. Okay, MRR. Okay, which is 130. Okay, 1.5 into 130.9. Your this answer will come into seconds. I told you, really be careful. That's it. Which is 3.27 joules per second. Okay, which is equal to what is joules per second? That is watt. Okay, so this answer will be 3.27 watt. This will be your answer. Okay, this will be your answer in watts. But they are answer one. So this is your power. Your power is 3.27 watts. Okay. Be careful about this thing. Okay. This MRR. I told you again. Okay. And in previous problem, again be careful with this meter because it is problematic. Okay. This minute. Be careful with this thing. It seems problematic. Okay. It is important. Okay. You to understand it. Okay. Because you have to take this thing. Because you made a mistake here. Okay. This thing is important. That will be again. So in this problem what we have, a slab milling operation is performed with a milling cutter of 40 mm diameter and 2 mm depth of cut. In a case of a feed for 2 feet taken to be 0.2 mm, the maximum chip thickness in millimeter is given will be. So what do you know the formula? Okay, what is your formula? So what is your formula here? T max, which is equal to F into 2 D divided by R. Okay, so you know your F is given 0.2 into what is D here is depth of cut. 2 into what is the depth of cut is mentioned 2. Okay, into 2 divided by what is your R, it is given at 40. So what is diameter? What is your R? 20. Okay, here you can simply find by this answer is 0.2 into 1 by 5 because it will be 4 by 20, it will be 1 by 5 actually, and the answer will be 0.0, just calculate 89 millimeters. Okay, this will be your answer. This is your final answer for T max. And if you calculate T average further, it will be half. Yes, okay. So this will be your T max. Okay. Right now we'll go for practice problem set. So In axial loaded member, during the strain measurement, which bridge is used to obtain the output? This is our question now. Okay, which bridge is used to get output? That is our question that we ask you. Okay, do you know what will be Mr. meter bridge? These things, this border bridge, harder bridge is not so you know it will be a Mr. meter bridge which is used to get output. Okay, you know like this it is connected. Okay, and this is something, and here we have a over voltage, and here we have a battery. Okay, plus and minus we have. Here we have a resistors. Okay, and this is how it will be used for meter which is arranged. Get axial strain measurement. This is what we get. This is how we can. So this is this is Wistron meter bridge. This is Wistron bridge. Okay, this kind of bridge is Wistron bridge. So Wistron is this kind of arrangement we are using. This is the galvanometer. This kind of arrangement we are using. This is called a Wistron bridge. Okay, so here this is the Wistron bridge. This is the correct answer. Okay, so a 40 minutes square cantilever beam is subjected to a normal force of 0 kN, and E is given to you, force is given to you, normal force is given to you, and E is given to you. E is given to you, normal force is given to you. The distance between the strain gauge and the point of application is 35. So N is given to you. Calculate the strain multiplied by 10 to minus 6. Okay. So you know what is the formula for that? You know E is equal to 6 into FQ. FQ divided by L into EBH square. Okay, here your B and H is same, so it will be 6 into FQ 350 Newton into L. L is 35 to 10 raised to minus 3. Okay, into what we have here E, which is 200. That is GPA 10 raised to 9 into B, which is B is 40 into 10 raised to minus 3 into 40 square, which is H square into 10 raised to minus 6 because it is square. So your answer will be 5.7421. Okay, 7421. Okay, this is your answer. Into 10 raised to 6 actually it is. So 10 raised to minus 6 actually. Okay. Into 10 raised to minus 6. Okay, this is your answer. What it is actually, just put the multiplication and put exact the same thing. Okay, like minus 3 you need to put correctly. Okay, into 10 raised to minus 6 will be your answer, but they have to put multiply by minus 6. 10 raised to minus 6 multiplied by 10. So you have to put just this answer, because in question they have mentioned that it must be multiplied by 10 raised to minus 6. What is your answer? 5 raised to minus 6 will be your answer. So what we put as per the question, what we put just this answer. Okay, because as per the question you need to put just this answer. Okay, you need to put this answer. Okay, why? Because they are given multiple tendency minus 6, that is as per the question. Okay, as per the question, this you have to put this answer. Okay, only this as put here. Okay, as you put here only this answer, because tendency minus 6 is already multiplied there. Okay, so right now we are at second problem, right? 80 millimeter to 50 millimeter, it is mentioned what is height and what is width. Okay, so it is mentioned this 50 millimeter is your height. Okay, so now h is equal to 50 millimeter, your b is equal to 80 millimeter. rectangular cantilever beam, you know your force, it is equal to 550, and E is equal to 200 10 raised to 9. Okay, in GPA it is given. Okay, and this will be your meter, so we have to take this condition giga per GPA. Okay, the distance between the gauge and the point of application force is L is equal to 25. Calculate the strain. You know again the formula. E is equal to, what is the formula? E is equal to 6F. It can be anything, F divided by E BH square. Okay, so we what is it? 6 into 550 550 okay, into 25 into 10 raised to minus 3. Yeah, because it is in millimeters. That is, and at this side into 200 into 10 raised to 9 into B. What is your B here? I told you 80. Okay, be careful about this. Okay, 80 into 10 raised to minus 3 into 50 square, okay, into 10 raised to minus 6. Okay, so when you do all the multiplication, you will get answer which is 2 point, is mentioned 2.625 into 10 raised to minus 6. But as per the question, again on the right, okay, as per the question, it is mentioned as per the question. Okay, as per the question, you need to write just this answer. Okay, as per the question, the answer is equal to 2.0625. But it is mentioned here multiply by 10 raised to minus 6. Okay, so this was your answer. Okay, in ring type dynamometer, the thrust force, they are asking for thrust force in ring type of dynamometer. Okay, thrust force force is measured by gauges placed at the angle of D with respect to vertical axis. Ring type and thrust force they are asking. You know, this will be your thrust force, so it will be 90. Okay, what is your thrust force? You must know. Thrust force is this. This will be tangential force. Okay, this is thrust force. Okay, remember. Okay, and this is tangential. That is actually curve cutting force. Actually, this is cutting force. Okay, this is actually a cutting force. Okay, and this is the thrust force. So what they are asking for thrust force. For thrust force, it will be 90. Okay, is their answer. And in ring type dynamometer, the tangential force is measured by gauge is at what angle? You know this angle. It is 39.6. Okay, okay, you know this. So answer. In ring structure, the anemometer with pitch radius of 20 mm thickness and 20 mm thickness of 10 mm and width of 5 mm is subjected to thrust force of 250 Newton. If they are given, you need to find calculate the strain multiplied by 10 raised to minus 5. Okay, so what here they are given thrust force. So what you need to find out, E 90 degree, which is equal to plus or minus 1.09. Formula will be FQ into R divided by E BT square. You have everything. Okay, okay, so plus or minus 1.09 into FT. F total is FQ. This is given 250. Okay, will be 250 into what is your upper circle radius? 20. Okay, and which is 20, but what is it? It is 20, but millimeters. And you have GPA 10 raised to 9. Okay, so you have to equal to 10 raised to minus 3. Okay, what is it? E 200 10 raised to minus 9 into what is your B? Your B is in B is width actually 5. This is 5. So 10 raised to minus 3 into your thickness, which is 10 square into 10 raised to minus 6, because it is square. Okay, you got everything, and then when you got everything, just multiply. Okay, after multiplication you will got the answer, that is 245 into 10 raised to minus 5. Okay, but question it is 10 raised to minus 2 multiplied. Okay, this given it is multiplied by 10 raised to minus 5. So your answer is equal to 5.45 will be your correct answer. Okay. Yes, the ring structure diameter with which radius is 20 mm thickness and 10 mm is given. The width of 5 mm subject to tangential force. Okay, so what they are mentioning tangential force. So what we will do? We have to change our formula now because the formula will be changed. The ring type structure is E39.6. It is equal to plus or minus 2.31. Okay, into F cube R into EV square. Okay, you see. It is exactly the same, just put. Okay, okay, okay. So it will be 250 into R, we need to put, which is 20, to 10 raised to minus 3. Okay, what will to put here now? E, which is 200 to 10 raised to 9. Okay, into B, what is the B? Again, it is 5. But 5 into, what is it is? What it is? 5 into 10 raised to minus 3 into 250. No, 20. No, is 10 square into 10 raised to minus 6. Okay, so this becomes 10 square. Okay, so thickness actually is 2 thickness square of thickness. Okay, this 10 square, and this is the squaring of thickness. Okay, so you have to multiply again with this 2.2. Okay, you have to multiply this calculation with this. Okay, this 2.91 into multiply. Okay, and when you multiply you get answer which is equal to 1.155 10 raised to minus 4. But as per question, the correct answer will be 1.155. Okay, next one. Okay, so which motion is possible in ring structure dynamometers when tangential force is applied? Okay, so you have a ring structure dynamometer. We have mentioned that you have a ring structure dynamometer. So consider a circle, and the tangential force is applied to it. Well, no, what is tangential force? If you left hand, you know what is tangential force applied to it. And this is your base. This is your base. Okay. So what will happen over here now? There is a chances of rolling. Simple. Okay. So correct answer will be rolling. In the ring kind of structure, due to tangential force, there may be chances of that will go here. Okay. Because that there is chances of rolling over here. So when tangential force is applied, the motion possible in the ring structure diameter will be rolling. Okay, I show you here. It is the center. This weight can be due to the tangential force. Okay, if like it is cutting actually, but it is tangential. But what is actually a cutting force? Okay, actually it is a cutting force in length specifically. Okay, when if you consider length, it will be a cutting force. Okay, this is your length. If you consider the length, this is the cutting force. Okay, and the rolling will be the correct answer. Okay, so after one structure dynamometer with a reference radius of 30 mm, thickness of 10 mm and width of 8 mm is subjected to a thrust force of 550 Newton. E is equal to 200 GPa. Calculate the strain. Okay, right now what they ask thrust force. Most important concept is thrust force. So we need to calculate for E90. Okay, because they are asking thrust force. Okay, so what is your E90 over here? Okay, yes. What is your E90? Your E90 degree is equal to plus minus 1.09. The formula will change because of the octagonal structure diameter. Okay, the formula will change over here. But it will actually say Fu by EB T square. So again put everything this plus or minus 1.09 into you have EF is equal to 500 into you have R 330 into 10 raised to minus 3 into port, okay, divided by you have E is 200 GPa 10 raised to 9 into what is your B? B is 8 10 raised to minus 3 into your thickness, which is 10 into square into 10 raised to minus 6. Just put everything and multiply it by this value, okay, because it is outside, so when you multiply this by this value, okay, what is your answer? 1.124 into 10 raised to minus 4. But your answer will be then, final answer is 1.124. Okay. For next question, okay. The octagonal structure dynamometer again, with each radius of 30 mm, same question, thickness of 10 mm, width 8 mm, subjected to a tangential force of 440 Newton. E is equal to 200 GPa, calculate straight. But tangential force, okay, and again, focus on what is asked. Octagonal structure dynamometer. In previous case, it is the point is different, okay, it is 2.31. And right now, your formula will change. Okay, it is at E50 is equal to plus or minus 1.4. So everything is the same, but it will be 1.4 into what you have a different factor here. Okay, EBT square. Okay, so what is this value will be? Put everything back. Code many times. Okay, so 1.4 you have to put plus or minus put here. And to your F is 450 and your R is 30. So 10 is to minus 3. Okay, it is important, you know, for following units. Okay, in E 200 into 10 raised to 9 into B is again 8. Okay, it is your 8 into 10 raised to minus 3 into 10 square 10 raised to minus 6. Okay, 10 raised to minus 6. Okay, and for doing everything, what will be your answer? That into multiply by 1.4. Okay, here you have to multiply by 1.4. It is here. Okay, multiply by 1.4. So you will get your answer. Okay, which is 1.1812 10 raised to minus 4. But your answer will be, you know, it is actually your actual answer will be equal to 1.1812. It is all a strings, so we don't have any need. Okay, so again we have some problems here, that is multiple choice questions. In an octagonal type dynamometer, the tangent force is measured by the gauges placed at an angle of with respect to vertical axis. What they are asking? A tangential force. Okay, tangential force was, you know, it will be cutting force, not a thrust force. So in that case it will be bend like something like this. Okay, the tangential force. Okay, so the angle is 50 degree. Okay, because of the structure, angle is 50 degree. Okay, it is mentioned in the slides. Okay, for octagonal type dynamometer, then your angle 50 degree. Okay, okay, your angle here will be 50 degree. It is mentioned here. Okay, 50 degree of your current transit. It is mentioned here. Again, which of the following is not a requirement of dynamometer? So they were asking that what are the what of these are not a requirement of dynamometer. Okay, this is simple asking this simple question we are asking you. Okay, what out of it what is not requirement of dynamometer? Okay, So what is not requirement of dynamometer? Sensitivity is a requirement. So what we are measuring? Force. So it is required. Yes, okay. So rigidity required. Yes, rigidity is required because it should maintain the stresses that the forces that will be generated during your machining. It will need to sustain that forces. So we require rigidity also. Again, the interaction is required. Yes, we require interaction also. Okay. So interaction is required here. So what kind of interaction is required? Because depending upon this cross signal, it is not cross reference is not being given to it. Okay. So this mentioned in the slide that if you are putting like here and cross signal should not affect it. Okay. This is and the different thing like we are putting different thing. Okay, like here we have put the different things. Okay, like here it is 1, 2, 3, 4, and here it is consider like 1 prime, 2 prime, 3 prime, and 4 prime. Okay, so interaction means this when this force is applied, like if the strain is in this direction. Okay, so this if this is strain in this direction, only this sensor will react. Output will be going only this sensor, not these sensors. Okay, so this is called interaction. So they do not have cross signaling at all. They should not have cross signaling here. It is not prohibited. So they must have interaction between each other. Okay, the cross signaling should not be possible here. It is again very required. You know the fact it is mentioned in the answer. So in this case, if the moment is here, only this stainless should give output. Okay, should give output, and for output from this we must be zero. Okay, this is called interaction. And tensile state is equal to dynamometers. No, it is not required. So, okay. So what is your correct answer? This tensile state is not required in dynamometer. But you are not going to the tensile or the dynamometer state. Tensile state is not required here. Okay. So this is your correct answer because you have mentioned which is of the following is not the requirement of dynamometer. Okay. They are asking which is of the following is not the requirement of dynamometer. So if you want what is not the requirement of dynamometer, then you tensile strength. Okay. This will be your answer. In order that the interference with cutting condition is small, the natural frequency of the dynamometer should be times the cutting frequency. Okay, get interference in order that interference of cutting condition is small. So it will be several times. It is mentioned because if you again start vibrating and that vibration may came into your force measurement. So it will be several times. Okay, it should be several times. So it will never go up to that. The natural frequency of the other part will never go up to this point, and the resonance will never happen. Okay, so this point you must consider here. Okay, what is that? Yeah, it should be several times. Okay, so that there is a no any condition for interference in signal. Okay, so the natural frequency will be several times. Okay, this is again the condition of for a dynamometer. Okay, it will be several times. Again, what is in reading dynamometer? How many strain gauges are used? You know, on one side you are using 8. What? How many sides we have? 2. So it will be 60. Okay. One side we are actually having is like 8 dynamometers here. 8, 8, 1, 2, 1, 2, 1, 2. Okay. So the 8 dynamometers this side. And it is mentioned in the slides. You can refer the slide. This slide structure we have. And this is center line. And here we have that dynamometer attached. Okay. This will be some kind of central line. And here your dynamometers are actually attached. It is mentioned very clearly in that slides. Okay. Here, here, okay. Here. Actually, there are 16. Here also the other set. This is the first set, and the other set will be provided here. Here the other set is provided. Okay, other set is provided here. So you have 60. Okay, total. Okay, you have total 60. So 60 is the answer. Okay, I mentioned where it is. Okay, so it will be 60 is the answer. In case of grinding operation, which dynamometer structure is used? So in case of grinding operation, they are asking which dynamometer structure will be used. So can we use ring in grinding? Actually, ring is can be used. It is not that much preferred. Octagonal ring we cannot use. We can use external ring. Okay. Cantilever again. This is for turning only. This is for turning only. Okay. And we are not turning here. Okay at all. So this is used only for turning. So this is not octagonal ring. It is less stable. Okay. This is less stable. Okay. But all of them are not stable. This is one. This is less stable even. But extend stable is more stable. Okay. That's your case of grinding operation, and they are told that this is our grinding workpiece, and here we have our octagonal extended structure. Okay, this is connected here, and here again we have a ring structure. This is the cage head. Okay, this is how it is placed and used. Okay, so this is your correct answer. Okay, this is your correct answer. As I mentioned, this is your correct answer. Extended ring, extended octagonal ring will be your correct answer. Okay, so why the slot is provided between the two rings of extended octagonal ring structure. So what is the use of that slot which is provided at I? So show like this structure is there and it is extended actually. This is extended structure is there and in this there is a slot. You see exactly there is a slot like a structure and the question is why this slot is provided. Okay, the question is why this slot is provided. Okay, this is our question. Okay, this slot provided. Okay, for what reason? So it is simply for sensitivity. Okay, so it will be more flexible and it will be more sensitive. Okay, that's why we are actually using the slot. Okay, the correct answer is sensitivity. It is mentioned here, the sensitivity. Okay, which of the below is and are modes of a tool failure? So we are right now going into use of tool failures. Okay, so right now we are entering into tool failure concepts. How the tool is failed. Okay, so fracture failure, yeah, it's correct. Temperature failure refers to thermal softening. What will happen here? Thermal softening. Due to what will happen? Due to thermal softening, what will happen? Fuel will get deformed. Okay. Due to this, the fuel will get deformed, and due to this deformation, it will lose its strength. Okay. And right now, what we have the gradual wear. If gradual wear is also due to flying fuel and creator, we are on gradual wear. Okay. So gradual wear is also possible. Temperature failure and fracture failure. All of these are possible. So what is the correct answer? All of the above. Okay. So your all of the above will be correct answer. So it is mentioned here. Your all of the above will be correct answer. Okay. So this all of the above is your correct answer because all of the mentioned things are modes of failure. Okay? Fracture failure, your temperature failure, gradual failure, all are type modes of failure. Okay. So all modes of failure. This will be your correct answer. Which of the below is not a mechanism of tool wear? This okay. So you know abrasive is yes because the chip tool interface there is abrasive. Addition again chip tool interface there is addition. Abrasive also there chip tool interface there is addition also. Okay. interface it is. Useful interface. Okay. And this location is not okay. Diffusion is again happening. Okay. This location doesn't happen. Okay. This location doesn't happen in case of pool. It does happen in case of workplace. Okay. Not in schools. It's not even reachable directly shared. So this is not even happening. Okay, at all. Mechanism of tool where this is not a mechanism of tool. That distribution is happening here, but it is actually converted into sharing here. So this is a correct answer. Okay. For two, this location doesn't happen. Okay. This will be a correct answer. Okay. Because in question what they have asked, which of the below is not the mechanism of tool here. Okay. So as they have mentioned not, this is your correct answer because the rest of the all nothing is average. It is correct. This is correct. This is correct. But this doesn't happen, so it will be correct. Okay. As it is a not answer. At high cutting speed, which tool wear mechanism is dominant? Okay, it is mentioned in that diffusion due to the why it use the rise in temperature. Okay, due to the rise in temperature, the diffusion processes diffusion mechanism is dominant. Okay, and what they have asked at higher cutting speed. The higher the cutting speed, your cutting speed is high. What will happen here? As your cutting speed is high, the temperature will increase. Your diffusion will increase. Okay. So what is the most common mechanism here? Is diffusion. Okay. When the cutting speed is increased, your diffusion will increase. Okay. This will be your answer. Okay. So it is mentioned here. What is your answer? Simply diffusion will be your answer. The tool wear on the rake face of the tool is called as. It is crater wear. On the rake face they are asked. So on the flank flex it will be flank wear. Okay. Know this fact. On the flank face it will be flank wear. As it is what they are answering here on crater wear. So on rake face they are asking. So it will be crater wear. Tool wear on the rake face. If they are asking flank wear, it will be flank. In flank face it will be flank wear. Deformation where is not happen. None of the above is not answer. So no, the correct answer is crater wear. Okay, crater wear. Okay, crater wear. You know how it is like this. It is happening. So this is a tool and this crater is happening. This is the whole known various cycle and we are getting to and this thing is happening. Okay, crater will be the answer. So in steady state where region the where rate of tool is rapidly increasing is not rapidly increasing, not uniformly decreasing, so not it is uniformly increasing. Okay, this is the correct answer. So is it increasing also and uniformly also? Okay, both the words are important. Okay, both the words are important. Okay, you to consider this thing. Both the words are important. Uniformly and increasing. Okay, the correct answer. It must be uniformly increasing. Okay, this is the correct answer. When the flank wheel grows up to this distance or this millimeter, the tool is considered to be as failed and it need to be taken out. What is the distance? It is mentioned in the slides. 0.3. Okay, this millimeter. The tool is failed. Okay, this tool is failed. You need to take out. Okay, okay. This is your answer. Which parameter has greatest effect on tool life? You know, according to Taylor life equations also. It is cutting speed. Okay. Only cutting speed has the greatest effect on tool life. Okay. This you know. Tool life equations are there. From tool life equations you can know this facts. Okay. Your work material will have the highest or the greatest effect on tool life. Okay. Your cutting speed. Variable affecting the tool life are tool geometry. Does it affect? Yes, it affects. Tool material, yes, it affects. Work material, yes, it affects. Cutting tool, yes, it affects. So all of this will affect. So this will be the correct answer. Okay. Then mention in the slides that your tool geometry will affect that is your alpha angle and your release angle. Okay, your relief angle will matter. Tool material, your hardness of material, workpiece of hardness material, cutting fluid, like various properties you have. Okay, everything will matter your tool life. Okay, so your that thing, everything matter on tool life. So it simply will be all of the above will be your answer. Okay, so this will be your answer, all of the above, because all of the above correct. Okay, as all of the above correct, so all of the above will be your answer. Okay, this is the answer, all of the above. Higher the strength of the workpiece material, the value of the optimum rail angle is. Okay, higher the strength means we need more area. Okay, more area. So for these cases, what is your rake angle? This is your rake angle. Okay, so this rake angle must be lower because we need to maximize this. Okay, okay. So it means this must be a lower. Okay, a lower. It is mentioned here. For higher strength of workpiece material, the value of optimal rake angle is lower. Again, with higher feed rate, the optimal value of flank angle is. As your feed rate increases, again, the strength of the tool is important. Okay, so maximum area for strength is required. Okay, max area for strength. Okay, so if you do this slightly, this over here will be a flank angle. Just we check it, change it slightly. If we change it slightly, okay. So this will be a flank angle, okay. This is a flank angle, release angle, okay, release angle, and you have to make it lower again, so that this area get maximum. Why? Because we are increasing the feed. Okay, as we increasing the feed. Okay, this thing you must remember. Okay, okay, so answer will be lower. So got this answer. The answer will be lower. So on the lake, the log table of tool life and temperature. With increasing temperature, the tool life decreases. In what way? Like hyperbolically, parabolically, linearly, or sinusoidally? So you know it is like this. The theta raised to m is equal to t with theta raised to m is equal to tool life. In proportion to tool life, something. Okay, or equal to proportion some c is there. Okay, this. This is linear. See, it is a log table. Okay, in log table, this value is linear. As we know this graph. Okay, as we know this graph here, as per this graph, this is your theta, your 2 okay. As it is going, we are going down. Okay, so the 2 will be decreasing. But how? In log table, this is the correct answer. Okay, C. Here, the linear will be the correct answer. As per the research of Professor Lola Ship. Okay, you must know this Lola Ship. The tool material must be at least 10 to 25. It is 35 to 58. This is the correct answer. Okay. Okay. It is by the researcher Professor Lowlands. Dr. Professor Lowlands is a scientist. By this, we know the material must be at least uh, 35 to 58% harder, okay, than the workpiece material. Okay, which action causes the work hardening of the material? Hence, tool must have high hardness. So, which action actually causing the work hardening in material? High tension, which is not happening. High bending, not happening. High shear stress, not happening. Not happening. High strain rate. Okay, due to that high strain rate, what is happening here? The work hardening will happen. Okay, which will again generate for work hardening. Okay, and due to this work hardening, what will happen? The hardness of the workpiece will increase. Okay, hardness of workpiece will increase. Okay, you know this fact will increase. Will increase. Okay, and due to this increase, what will happen? The tool must have more hardness. Okay, tool must have high hardness because of the high strain rate. The work will get strain hardened, and due to this effect, we need a higher tool. Okay, like say just like 30 to 50% more because to compensate for the hardening of the material. Okay, this is the correct answer here. The hardness because in the case of tool, nothing is happening. Okay, the force will not give you, but at maximum temperature will be there, but the shearing is not taking place in tool. So where it is taking place, where the hardening is actually strain is taking place, more amount will work. So the work will get harder, and due to which hardness will increase, and due to which the tool must be more harder to cut that material, which is strain harder. Okay, this is the reason. High strain rate is the reason for that phenomena. Okay, mentioned here the high strain rate is your reason. Okay, this high strain rate is the reason. Okay, so again, which thing does the cutting fluid serves? Okay, avoid thermal expansion. Yeah, it is. Yeah, it is avoid check the heat. Okay, take away the heat away. So when you take the heat away, thermal expansion will be okay. Okay, first to layer of finish surface because we are adding some additives. Okay, some additives we have added due to which it is correcting the function. Choose from the machining area is again the correct. Okay, it will take due to high speed. It will take chips from machining area. So all of the above will be the correct answer. Okay. You got what is the correct answer? All of the above. Yes, all of the above will be the correct answer. Yes, all of the above will be the correct answer. Which are the properties cutting fluid must have? Okay, like high specific heat, yeah, to get more amount of heat. Okay, convert more amount of heat. Okay, what you must have specific heat to good thermal conductivity. Okay, for conduction it must have good thermal conductivity. Okay, to take away it. Okay, a chemical constituent for weak junction. Okay, to form a layer. Okay, layer formation. to prevent what? Welding. Okay, to prevent welding. Okay, so this is required, is required, so everything, all of the above is required. Okay, so what will be the correct answer here? Strictly all of the above will be your correct answer here also. Okay, because everything is required. Okay, which of the proper? But it must have high specific heat to be that as to be. Okay. Which are the properties cutting fluid must have? Gain low viscosity. Yes. Why? To reach the cutting zone. Reach up to the cutting zone. Wall volume the bed, same for this is a non-corrosive. But it should be non-corrosive, okay? To prevent UV machine surface. Okay? So it must be non-corrosive. It should not corrode the newly machine surface, okay? So everything is required. So what is your answer? Simply all of the above will be your answer, okay? Which are the properties of the cutting fluid must have? All of the above will be your correct answer, okay? So, see. All of the above will be your correct answer. At very high speed, the cutting fluid is reduces the friction. No, it is the friction. No, inefficient. Yes, all of none of the above. No. Yeah, it is mentioned because it is stable in that that if this thing will happen and when it is cutting, you go up to this to more units. So what happens is that your force and your friction also like friction also it becomes same because sometimes the friction also become inefficient. So at very high speed, what will happen? It is ineffective. What? Your cutting fluid. So your cutting fluid will be ineffective. Okay. This cutting fluid will be ineffective at very high speed. Okay. So it is become ineffective with your correct answer. Okay. What it will be? High velocity cutting fluid is used to what? For what reason? Increase the temperature. Can it increase the temperature? No. But it will take the coolant, it will take out the temperature. So this is not option. So it will increase the friction? No. Because it will reduce the friction actually. Okay. What is the use of cutting fluid? Reduce the friction. Remove the chip from machine? No. Yes, it is correct. And none of the, all of the above is wrong. So all of the above, these two are wrong answer. So all of the above is wrong. So what is the correct answer? Yeah, this is the correct answer. High speed will take away all the chips which is present in the machining area. Okay, machine zone. So answer will be remove from the machining zone. So what chips? To remove the chips from the machining zone. So it will be the correct answer. The following figure represents which operation? Okay, this is we are creating a 45-degree angle. Okay, to so that it will be guided to when you are inserting for assembly for assemblies it is needed. Okay, for assemblies. So it will be it will guide to the center. Okay, to assemble this chamfering is provided. Okay, so this will be chamfering. It is facing. It is not facing. The facing operation right. Okay, it is done like here. How the facing is done? Suppose your facing is done in this opposite direction. Okay, these are two facing is in this direction. So how it is doing? It is not moving in this direction. Okay, it is just going a 45-degree angle. Okay, like this. This 45 angle is provided over here. You see, for the assembly. So it is not facing. Okay, so a facing operation is different. It is perpendicular. The tool moves perpendicular to the motion or to the axis. So this is your axis. The tool is perpendicular. This is called facing. But it is not facing. And this process, the countering is different. This is not countering. Countering is like other like form. Okay, this like some form. If they have it from a countering. Okay, this is not a countering. Okay, and cutoff means completely cut off the material. It's not a cut off operation. You know how cut off work. This is shown in the slide. Here it will cut off means it will do some things like parting off into two parts. So what will happen? This job and this job will be separate. Okay, this is not happening. So cut off will be not. So chamfering will be correct answer because it is actually given a 45 degree angle. So you know what is it doing? Creating a 45 degree angle. So this is your correct answer. Chamfering. So if you had chamfering, chamfering is your correct answer. Okay, chamfering is your correct answer. Okay. Chamfering could be your correct answer. The following figure represents which operation? Okay, this is threading. This is not threading side different. Okay, like this will be happen. This is not threading operation. Okay, boring is internal. So boring is different. You know, boring bar. It is different. It is internal threading. Okay, or internal machine gallery boring. Nulling, yeah, it is nulling process. And threading is again different. So what option we have? Only nulling process. Nulling is like creating a texture surface. Okay, texture surface or creating for gripping. Okay, what is the reason for gripping? You are going to take charge surface. Okay, so this is a nulling process, and this is actually nulling process. Okay, this will be the correct answer. What nulling will be the correct answer. So it will be shown here. What will be the correct answer? Exactly, the nulling will be your correct answer. It is nulling operation. Okay, which work holding method in lathe has self-centered feature? So dog plate have? No, it doesn't have. Collet have? No, it doesn't have. Illustrated feature faceplate? You don't have. Four jar chuck? No. Three jar chuck? Yes. Okay, only three jar chuck have the self-centering feature. Okay, okay. It is mostly used for circular inlet and it has a feature which is called a self-centering. This is again important. This self-centering feature is important. It has a self-centering feature. Okay. Four jar chuck is not faceplate also don't have. Collet don't have. Dog plate don't have. So only three jar chuck will have a self-centering feature. Okay. Okay. Video check will be your answer. Okay. So your answer, video check. The operation in which the machining is performed on the inside diameter of an existing mold is called as I mentioned previously also. Turning is for external. You know this fact. Turning is for external. Pouring is for internal. Okay. And drilling is a bit different and facing is completely different. Okay. It is though not forming hole at all. So what is your answer? Boring. So boring is correct answer. You know. I told like this we have and the boring will be used to what? Just like tool structure we have and this machining of internal machining of internal structures. This internal machining is done here by boring. Okay, this is the internal machining. Okay, it's called as boring operation. Okay, so what is creating a hole? This is this kind of hole is there. So this is an axis and this is hole is there. And what it is preparing? What we are preparing here? Hole we are preparing. Adding this system. Okay, boring operation. The operation in which answer is clear. Boring. The operation demonstrated in the following figure is called as what kind of operation is this? Is it a reaming operation, boring operation, threading operation, or tapping operation? You know reaming when reaming is done. When reaming is done, when you first perform the drilling operation, then to increase the surface finish. What is the surface finish of what? Holes. Okay. Boring again. It is internal turning. Internal machine is something not turning, internal machine. Internal machine. Okay, and drilling again, material removed the holes. What left? Tapping only. Okay, this is for internal threads. Okay, so how internal threads can be made? By this. Okay, so this teeth will be present here. Okay, this is your diameter of the teeth or a drilling turn threading operation. This is the diameter of a threading operation. Okay, the tapping is the correct answer. This is a called tapping process to get the internal threads. Okay, so this is the correct answer. It is called a tapping. Operation demonstrated in following figure is called as. Okay, so here we have one figure. Here one operation is shown. What is it? It remain, you know what is remain, so it is not there. Okay, you know what remain process is. This is not remain. Counter boring. So it is a counter boring process. Drilling process is not like this. It's different. Tapping you of yours and what will be like production of thread. Okay, internal threads. You are tapping. But here we are not doing that. You are not doing that. Okay, what we are doing? Counter boring. So this is counter board. You know how it will look. It will look like this and this. Okay, you get the head of your bolt. Okay, for bolt head. What is use of it to get to fit the bolt head. Okay, to fit the bolt head. Okay, it is required. Okay, so how it will look like this. Okay, so this will look like something like this. Okay, your body. Okay, so here the bolt will be the head will be there. And here this is your desktop here. Okay, so what for this reason we are doing counter boring process. Okay, this is the actual reason behind the counter boring process. Okay, so this is not a ringing process even. This is not drilling and this is not tapping. Counter boring is the most perfect answer. Okay, it's the most perfect answer. Okay, it should be the most perfect answer. Okay, counter boring. It is mentioned. It must be a counter boring operation. So the parameters X from the drilling tool demonstrated in the following figure is called as. So this is drilling tool. So this is your what is this? What is this? This is your lip. So this is your lip. This is your cutting edge. This is your edge. This is your lip. Okay. So what asking cutting angle? This is not a cutting angle. Actually, this is a cutting angle. No, cutting angle is like point angle. It is different. Cutting angle is here, not here. Cutting angle is different. It is not cutting angle. Relief angle, yes, it is a relief angle. You know, it is relief. The angle is not relief. So the other point angle is this. Okay, this is a point angle. So only the relief angle is the correct answer. It's always relief angle. Okay, but it's generally, you know, like this is your leaf and it is like this. So this angle is your. It is not shown perfectly in this diagram actually. What is in the syllabus? So like this and this. It is like this. We have edge. Here the chisel edge is called as. This angle is your relief angle. Okay, which is called as normal relief angle. Okay, this is your relief angle. This angle. Okay, so it is X, which is your relief angle. Okay, this is your relief angle. Okay, okay, the answer is correct. This is your relief angle. So in Taylor's two life equation, unity and the n is the. So what is the n over here? Asking. N is slope of the plot. No, the intercept of the speed axis is c. How? you know what is your C, this is your C, this is your cutting speed. Intercept of this is your V, is cutting, which is your tool line. This is your slope. So when we extend it further, so this will be a C. If intercept of the constant axis is C. Okay, if we extend this further to C, this is called as C. How? T is equal to 1. Okay, it is mentioned for cutting speed for 1 minute to life. Okay, you know what is your equation? V into 10 is to N is equal to C. The intercept of the x-axis, you know what is the intercept of speed axis? If we go to this axis actually your C. Why it is, you know, it is intercept of x speed axis? It is C actually. This is the, you know, point, you know, this is the theory. This is constant, then this is correct. It is C. These are all for C, and N is this correct answer. Okay, for N, this is the correct answer, which is the slope. And for this, it is C. Intercept on speed axis, you can intercept, you can have intercept here, which is called as C. And again, cutting speed for 1 minute of full lap. So this is our equation, and your V is 1. So cutting speed for 1 minute of 2 laps. We have V. What is your T here? This is 1. 1 raised to N. So anything raised to 1 is 1. So it will be, what it will be? V is equal to C. Okay. Because of, so this is again cutting speed for 1 meter of 2 laps. So your V and our C is constant. So what is your C? All these that A, B and D is for C value. Okay. It's multiple choice question. So your V and C is equal when at T is equal to 1 meter, 1 minute. For 1 minute, in the Taylor's to life equation, for 1 minute of full life, you are cutting. This is why you can say that it is intercept. Okay, why you are taking it is as an intercept? Because when your V is, your T is 1 here, because it is a log scale. What do you tell? What we told here? Okay, what is Taylor's life equation? It's a log scale. What is the log of 1? 0. So what is this? 0. So it is 1. Okay, at value of 1, where it should intersect at cutting speed. So speed axis. So this is why this part we consider here intercept on speed axis. Again here what they are asking, cutting speed for 1 minute of tool life. So okay, this is our tail life equation. We put T is equal to 1. It is again meter per meter per minute. Okay, but the speed. Your tube your tool will be life in minutes. Okay, so we put 1 minute here. Anything less to 1. So 1 less to what, where you can put 12 or infinity or infinity, but you can put any n number. We are asking for n number. So mostly it is equal to 1. Yeah. So it will become 1, 0.4. Anything less than it will be 1. Okay. So this will equal this. So correct answer. Cutting speed for 1 minute will be, yeah, this will be the correct answer. So this for what? For C. If you can see, then it will be correct answer. But right now, what you are asking here? Okay. So right now, what you are asking here for N. So this is not the correct. But if it is C, it is actually your assignment. So it is multiple choice question and again multiple answer again. So these all things are for C. Okay. So what you can conclude? I explain everything. So these things, this, and this is for constant C. Okay. And only this is for N. Remember this thing. Okay. You must remember this thing. Okay. Okay. Right now we have problems again. So it is problem 43. Okay. 43. This is 43. So what they have given to us here? Check what they have given. What they have given. V they are given. Okay. 1.833. But it is what unit in meter per second multiplied by 60. Okay. You get some 109.98, which is approximately 110. minute, 50 meter per minute. Okay, so you have T now. Okay, you have the equation actually. Wanted to find now question track. You want to find T. Increase it to life. You have to find T. Okay, so what your T? The to life equation V T is to N is equal to C. So what is your V here? 109.98. Color. Okay, answer start here. Okay, into T. You need to find out N is given 0.01, 0.140. Okay, it is T. And our constant is 140. Okay, this equation we have. What is here? They are given U given N is given, C is given. Okay, so what it is? V T into 0.140 is equal to 140. Okay, this is the actual answer. Okay, equation. And what they have asked you for to present the percentage increase. Okay, so right now we are calculating for percentage increase. How you can calculate percentage increase? That I am showing from this part. Okay, from here. So here we can find the T. So how you can find the T? T is equal to, it will go that direction. V 140. It will go in that direction. It will equal 140 into 110 divided by that. Here it is raised to. So when put to that side, it will be minus. So it will be like this. Okay. So your T is equal to 5.598 minutes. Isn't it like? And next, what they are asking, if your C is 35% increase. So what right now what we will see ended here. So right now what if you will see will come that Vt raised to 0.140 into C is what? 140 into 1 plus 0.35. Okay. So your Vt into 0.140 is equal to become 189. Okay. So again you need to find out the T. So what is T here? Just fast process 189 by 110 divided by your, everything is same. Okay, so just your C exchange. So in this case, what is your T you will get? So your T will be 47.76 minutes. What they are asking? Percentage increase. Okay. So what is your percentage increase then? Simple. We know the both the answers 47 and 5.598. Okay. So your percentage increase in T will be, it will be 47.76 minus 5.598 divided by 5.598. So it will be 753%. Okay. Your increase in T life is this much. It is just hypothetical computation. Okay. So again, two life test in a cutting operation in the following data. You have the following data now. So what that following data is saying to you, you have V, but what is the value of that V? 2 meter per second. We don't want that. We want it meter per minute. So multiply it in first case. We are writing for first case. Your V is equal to 120. First simply multiply. What is your T? T is given in seconds. What in minute? So divide by 60. Okay. So how it will be 12. So T is 12 minutes. And again in our second case, in your second case, V is equal to, the mention directly, 95 meter per minute, and your T is equal to 55 minutes. So calculate the value of N. What is the value of N? You have to calculate, okay? Value of n and value of c will be calculated. So how we can calculate? You know v2 raised to k is equal to c. So what you can put here? Calculate both the equations. We have two unknowns, two equations. It's very easy. Okay. So it will be 120 into 12 raised to n is equal to again 95 into 55 raised to n. Okay. So take log on both the sides. It will be ln 120 plus n ln 12 plus is equal to ln 95 plus n ln 55. Okay, calculate everything and do proper subtractions, and what you got as an answer, it will be 0.2332 is equal to n into 1.5221. Okay, so your n is equal to 0.1532. Okay, we got n now. So once you got n, just put n in any of this equation. What you have, you got n in. Put this n in any of this equation. Okay, you have a c. Okay, this is actually equal to c. So from that, what we can calculate, we can get the actual equation. We have no the equation, that is vt. What is your n, which is 0.1532 is equal to 175.59. So here what we have, you have v, which is equal to what we have here. We have v is equal to 100 meter per minute. What you have to calculate? T. Okay, so what we will calculate T? It will be 100 into T raised to 0.1532. Okay, which is equal to 175.59. So from this, what we can calculate? T. Okay, you know that 175.59 divided by 100. Okay, raised to 1 point minus this 0.1532. Okay, this point. So you know what is the T? Equal to 39.44 minute. This is your T. Okay. Now what in second case we need to find out? V. Okay, but you have T is 140 minute. Okay, you have T 140 minute. Okay, so put like exactly like this. So what is your equation then? V, it will be unknown, 140 into raised to 1.32 is equal to 175.59. Okay, so this will go there, and if you want to raise to 0.1319 actually is equal to 175.59. 5 is 59. Oh, it is 5959. Okay, so your V is equal to 82. If you calculate it, divide this. What is that? Just divide 175 by 2, like 1.219. Save the number 80. 82.35 will be your answer. What is per? It is meter per minute. Don't forget it. Okay, this will be your answer. Okay, so everything is answered here, and all the questions are solved for you. Okay, with different colors. So right now 45 question. So a 2 lakh equation is given. What is it? This is very simple than previous. 0.35. It is equal to 480. What you have to calculate? Just speed. Add the speed of. So you have v, which is 1.8. That's what you do, multiply by 60. It will be this value 108. Okay, 108 meter per minute. Okay, because it's meter per second. It's again fairly easy. Okay. Right now, what we have T is 108. What will be like with T into 0.35 into 480. So what will we do? Again, simple T is equal to 480 divided by 108. Okay, divided by 0.35. Because there it is raised to here to alpha. So 1/35. Okay, so again simple random answer. So T will be 42 seconds. T will be 70.94 minutes. So your what you're asking in seconds. So just multiply this by 60. So your T will be 4256.55 seconds. Okay, this is seconds. Okay, this is seconds. Okay, so this will be your answer to life in seconds. Okay, this is 94. Okay, so this is your answer 1256.5. Okay, then we have one more last question. I think. Yeah. In production, turning operation, the work part is 150 millimeter in diameter and 500 millimeter long. The feed rate, so what they have given, feed rate they have given, so let's copy some different color. The feed rate they have given 0.38 millimeter per revolution. Work part is diameter is given 150 millimeter. Length is given 500 millimeter. So the velocity cutting speed they are given meter per second, so converted to meter per minute. Is 500 meter per second. Just multiply it into 60 dB. One. Oh, well, 300 and second one is 150 divided 2.5. It will be half. So equal to 150 meter per minute. Okay, but you don't have what? You don't have Tm. But what have given? They have given other parameter. Yeah? So Tm is equal to change the color. That's Tm is equal to T is equal to L by Fn, and your dc is equal to pi dm. Okay, so your n is equal to dc by pi d. So what it become now? It will be L by your pi d will go up and it will be Fn dc. Okay, this is your formula for time. Okay, so what is your time here? Now calculate. L you have 500. You have pi, yes. You have d, yes, 150. What you have? F 0.38. What else you have? EC pi for first. So it will be 124.010. For second case, same. Everything is same. Just the DC will be changed. This half. So what is changed? The denominator change. So I come to half. So your numerator, your answer will be simply multiply by 2 because it is half. That's simply. Okay, you will have to have your TM. Okay. What you need to find out right now? You have V, you have T. You need to find your N and C. Okay, so what is again? You have to find N and C, which is actually question. You need to find that 2 points. Okay, let me go with green color. Vt is to N is equal to C, you know, so it will be 300. I'm putting directly right now. 300 into 124 into N, it is again equal to, because it is constant, 4 is constant, so 150 into 248 is N, which is C. So take a log on both sides, and 300 plus n. Okay? It is log n ln 124. It is plus equal to ln 150 plus n ln log of 248. Okay. To do everything, it will be 0.69307 equal to n into 0.6932. So your n is equal to 0.099981. And once you have your n, what left? You have n here. What left? See, put 3 there. Okay. So you have here. So you know your n. Put c. Where you can put c in your equation. We have many equations there. So you can put any one equation. Just 3 into 124 into 0.99981 is equal to c equal to 37165.945. It will be c. So v t raised to 0.99981 equal to 37165.945. Okay. So this will be your answer. Okay. This will be your answer. Here. So this will be your answer. Okay. So here we end our lecture. This is your last slide. So if you want the certificate, then you need to register for the exam, and the last date for exams are just 3 days left for registration. So 20th August will be the last exam, last date for registration. Okay. So 20th August is the last date. Okay. 20th August is last date for registration for exam. Okay. So if you want to register for exam to get certificate, you need to register before 20th August. Okay. So the 20th August is last date for registration. Okay. If you want a certificate, do register before 20th August. Okay. This is the case. Do register for exam. So before 20th August is your last date. Okay. 20th August. So do register for it. Okay. To get a certificate. Okay. Okay. So this is the case. Do register for it. Okay. Thank you.